So good morning, everyone. I always forget whether it is morning or afternoon. And welcome to today's lecture. This is lecture number 11, and we are dealing with vibration of air column. Basically, we are dealing with organ pipes, open and closed. Closed means it is closed at one end and it is open at the other end. And do you remember nodes, anti-nodes for this one?
Yes, sir.
We had seen that this open pipe open pipe basically means now this closed pipe is basically like a string which is fixed at one end. We had seen the general formula as well in terms of overtones. We remember this formula, yes or no?
Yes, sir.
Okay, then we had seen this open organ pipe which is same as string fixed at both ends. The only thing are we have antinodes at the open end. Remember, these are antinodes of displacement and not pressure. Because in terms of pressure, the wave looks like this. Remember, these are pressure nodes, and these pressure node actually do not happen at the end. They happen at a distance 0.6 r from the ends, and that is known as the end correction. And open
Incorrect.
pipe
Yes.
has two end corrections, whereas as closed pipe has only one end correction. Do we remember this?
Yes, sir.
Now today we will solve some problems on this so that we are able to solve the problems in the exam. And I'm looking for problems on pipes. Let us start with which one? Okay, let us start with this one. Let us start with this one so that you have an idea about what types of questions actually come in your exams. And you can see the questions are quite simple. This is question number 1. An open pipe is suddenly closed at one end. Open pipe becomes a closed pipe, with the result that the frequency of the third harmonic of the closed pipe, remember third harmonic of the closed pipe, is found to be higher by 100 Hz than the fundamental frequency of the open pipe. What is the fundamental frequency of the open pipe? The pipe is same. It was open, now it is suddenly closed. Third harmonic of the closed pipe is found to be higher by 100 Hz. Do you understand the question?
Yes, sir.
Then you must tell me the answer for this one. I'll give you 2 minutes to give me the answer. You must remember what are the fundamental frequencies, third harmonic, what is mean, and all those. You remember those? Yes or no?
Yes, sir.
Let's see if you can give me the answer for this one. So basically, the first one was an open pipe. The fundamental frequency of the open pipe. What is the fundamental frequency of the open pipe? Huh?
V by 12, sir.
V by 2L is the fundamental frequency of the first open pipe. Suddenly closed, and the third harmonic. What is the third harmonic?
3V by 4L, sir.
Third harmonic is 3V by 4L. What is the relation between the two?
Closed pipe.
Huh?
Sir,
What is the relation between the two? The third harmonic is higher Then the first harmonic by 100. Yes or no?
Yes, sir.
From there you will get the value of V by L. Once you get the value of V by L, you can find out the value of V by 2L, which is the first harmonic. Yes or no?
Sir.
Should you take so much of time to calculate this?
No.
Huh? Okay. See, we are putting in so much of effort, so that so much of effort should translate into results. Do we understand this, or this is gone above our head saying bye bye?
We understand.
I don't see conviction in your faces. Your faces are still looking like big question marks on them. Big question marks?
No, sir.
Pakka na sir?
Yes, sir.
Okay sir. Then what about this one sir? Any idea on this one? And I need the answer quickly also. Not only the answer, not only the correct answer, but answer quickly. This is from IIT-JEE. An organ pipe P1 closed at one end, vibrating in its first harmonic. Another pipe P2 open at both ends, vibrating in its third harmonic. And in resonance. Resonance means same frequency. Do you understand the meaning of resonance? Huh?
Yes, sir.
With a tuning fork. This tuning fork is going to come more. The ratio of the lengths of P1 and P2 is. Huh? Any idea? No idea. Get idea. So much of time is not available for questions like this. You must understand this. If you want so much of time for these questions, it may not be available, bacha. So much of time is not available for this question.
One by six, sir. C.
Taken so much of time is not available, as I told you. First harmonic of the pipe P1 is V by 4L1.
Yes, sir.
P2, third harmonic.
3V by 12.
So much of time is not available, no beta. So much of time is not available. 3V by 2L2. From
Yes.
here you have to find out the ratio of L1 by L2. It has to come 1 by 6. Try and understand this. So much of time is not available in the examination hall for these questions. Because for this question, if you are taking so much of time, that is not. And right now, when we are doing this topic, you should not take so much of time for doing this. Remember, your exam is still, the attempt that you are going to give seriously is still 3 months, 4 months away. If you can't do it here now when you are doing the topic quickly, it means you will not be able to do it in the examination hall. No chance. Next one. A tube closed at one end containing air when excited produces a fundamental node of frequency 512. If the tube is now open at both ends, what is the fundamental frequency?
A, sir.
1024. A, sir. How did you get A, sir? It's very simple, sir. Fundamental node of an open pipe, of a closed pipe, is V by 4L. And this V by 4L is 512. Now it becomes an open pipe. For open pipe, it should be V by 2L. So the fundamental frequency has to be V by 4L is 512. So V by 2L is 1024. The
Yes,
answer
sir.
is 1024. Straight away.
Yes,
You have
sir.
to get these questions quickly. If you don't get these questions quickly, then you will not be able to do much in the examination hall. Next one, this one. A cylindrical tube open at both ends has a fundamental frequency F in air. Remember, I gave you this thing as probably a note. The tube is dipped vertically in water so that half of its length is in water. What is the fundamental frequency of air column? Now, what is the fundamental frequency now?
P, sir.
Hmm?
F.
Length becomes half. I told you it becomes a closed pipe. Length becomes half. Fundamental frequency remains. Will become same. I gave it as a note. Yes or no?
Yes, sir.
Chalo. See, the same question gets repeated. This one.
D.
We understand this, or this is gone above our head saying bye bye?
We understand, sir.
Pakka?
Yes, sir.
This one. A pipe of length 85 centimeters is closed from one end. Find the number of possible natural oscillations of air column in the pipe whose frequency lie below 1250 hertz. The speed of sound is 340 meters per second. Any hope of getting this one?
Yes,
No
sir.
hope, sir.
Yes, sir.
What, sir?
We'll get on.
Let's wait for the answer, sir. So how are you supposed to do this whenever such a question comes, where they ask you how many things are possible? Okay, it is a pipe closed at one end. You can do it in different ways. Close at one end. You can find out the Fundamental frequency. Speed is also given 340. You can find out the fundamental frequency. How much is the fundamental frequency? F1. Huh? Speed of sound, C. Let me not write it as V. Let me start writing it as C because that is what I'll be using in the next class. C is the speed of sound divided by 4L. Yes or no?
Yes, sir.
How much is that coming? Huh?
అది cancel. 1250, sir.
Huh? Multiply and divide. It will be coming as 100 hertz. Yes or no?
Yes, sir.
What are the frequencies possible? Remember, this is an open a pipe closed at one end. The first one will be 100. What will be the next one? Odd harmonics are present. So next one is 300. The next one is 500. The next one is 700. The next one is 900. The next one is 1100. And the next one is 1300. How many are possible below 1250? Count. 1, 2, 3, 4, 5, and 6. That is the answer, my dear friend. 6. That is one way of doing it. That is one way of doing it. The other way is by using the general formula. I had given you the frequency,
Sir.
wavelength ka general formula. From there you can write the wavelength ka general form, the frequency ka general formula. The frequency ka general formula, you can just add it there only. The frequency ka general formula will become how much? Frequency ka general formula will become how much? You can add that frequency ka general formula also. This was the general formula for the wavelength. What will be the general formula for the frequency? Add it. What will be the general formula for frequency? Huh? No one knows it. Array frequency. V is equal to F lambda. So frequency is V by lambda. V by lambda. V by lambda. The general formula of frequency becomes 2m plus 1 divided by 4L times lambda, where m is the overtone and m starts from 0, 1, 2, and so on. Do we understand this, or this has gone above our head saying bye bye, sir, मैं जा रहा हूँ, I'm going, bye bye, I had enough, I'm leaving this universe, going into some other one. This is the general formula for frequency of closed-ended pipe. Similarly, you can write the formula for general frequency for an open-ended pipe. What will be the general formula of frequency for an open-ended pipe? Huh?
N plus 1 by 12.
God exists, see? N by 2L into V, where N stands for the number of overtones starting from 0, 1, 2, 3, and so on. Now, using this general formula, I can do this question for frequency if you want to do it by the general formula. General formula of frequency for an closed pipe was how much? 2m plus 1 by 4l multiplied by v. And this should be less than 1250. From here, you can find out this is a simple inequality. This is a simple inequality. This is a simple inequality. From there, you can find out the value of m. Remember, the value of m starts from 0. From here, putting the values, you can find out the value of m. And I think the value of M will come less than 5 point something, 5.2 something. So M should be less than 5.2. That means M will start from 0, 1, 2, 3, 4, and 5. The number of overtones are 6, my dear friends. So you can do it in this way or you can do it in that way. The answer comes same. Do we understand this? Or this has gone above our head saying bye bye sir, I'm going sir. Bye bye sir, I'm going sir. Bye bye sir, I'm going sir. Huh?
We got it, sir.
Got it is difficult to imagine. But then I will give you, I always felt that students are like cash vouchers. Sometimes the cash voucher may not work, but that's not the problem of the cash voucher. That's the problem of the person who is putting in that cash voucher. Cash voucher always works. So this is another chance to redeem yourself. Redeem, 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 redeem with this question. A closed organ pipe has a fundamental frequency of 1.5 kilohertz, my dear friends. The number of overtones that can be distinctly heard by a person with this organ pipe will be same question put in a different way. Let's see if we have anything that can help you in solving this question. You shall have 2 minutes to give me the answer. So that is the correct option. You don't have to even find out the fundamental frequency here because, my dear friend, the fundamental frequency is already given to you. The value of F1 is already given as 1500. The value of F1 is given as 1500. So what are the frequencies possible? The first one is 1500. What is the next one?
Next one, 3. Oh,
4500.
yes, sir. 45.
Next one,
5.
7500. Next
Yes.
one,
9. 9,000. 9,000. అది 9,000.
take a deep breath. 10,500.
ఇది 5 కదా.
Then
13,500.
thank God. God exists. See, I always believe that God has gone. God exists. Next one,
16,500, sir. 16.
next one,
20,000.
take a deep breath and give me the answer. 19,500. This is the table of 15. 15 ones are 15, 15 threes are 45, 15 fives are 75, 15 sevens are 105, 15 nines are 135, 15 elevens are 165, 15 13s are 195. So how many are possible? 7. You could have done it in that way also, using the general formula. Frequency, the general formula is 2m plus 1 into V by 4L. Now this V by 4L is already given as 1.5. This should be less than 20,000. Yes or no? No or yes? So 2m by L, 2m plus L into 1500 is less than 20,000. From here you can get the value of M. I think M will come less than 6 point something, 6.1. So M starting from 0 to 6. These are your fundamentals. Do we understand this or this has gone above our head saying bye bye sir, I'm going, bahut ho gaya, enough. Things are simple. They are as simple as you want them. And they can become as complicated as you make them. Do we understand this?
Yes, sir.
What, sir? Next question, sir. Remaining on stationary waves, sir. Give me the answer for this one, sir. Now comes on strings. String, string, string. String, string, string. String, string, string. String, string, string. A string 2 meter long and fixed at its end is driven by 240 hertz vibrator. The string vibrates in its third harmonic. String fixed at both ends. Remember, things have changed. The speed of the wave and the fundamental frequency is. You have 2 minutes to give me the answer. So, how are we going to do this? String is fixed at both ends. The frequency is 240 hertz and it is in the third harmonic. So you can find out the fundamental frequency. What will be the fundamental frequency?
D, sir.
Huh?
D.
Arey, not D. What is the fundamental frequency?
D and Leda. Sorry. ఏమనలే.
3 times F1. Third harmonic, the frequency is 240. The fundamental frequency becomes 80 hertz. So option number C and D go away. Rain, go away. We just have to find out the value. This is a string fixed at both ends. The fundamental frequency is for 80 hertz. That must be equal to V divided by 2L. Length is 2. 2 into 2 is 4. 4 into 80 is 320. And the correct answer is option B. Is it so difficult to give this answer?
No, sir.
Huh? Tell me, is it so difficult?
No, sir.
How many of you could do this? Only one, two. Arey yaar, whatever I do, nothing. Okay. This one, last one, to show your talents. Whether it is a question of string clamped or it's a question of open-ended pipe or a closed-ended pipe, everything is simple. Comes this one, my dear friends. A string clamped at one end. A string clamped at both ends. It's vibrating in its fourth harmonic. The equation of the stationary wave is ding, ding, ding. What is the length of the string? I need the answer fast. If I don't get it in 1 minute, that means you are not able to do it. It's that simple as that. So I have an answer here. And the answer is 40. No, the answer is 80. 80, 80, 80, 80, 80, 80, 80, 80, 80, 80, 80, 80, 80. Fourth harmonic. Fourth harmonic, it is oscillating. The length of the string we have to find out. How will you find out the length of the string? Fourth harmonic. What will be lambda equal to for fourth harmonic? Lambda for fourth harmonic will be how much? Lambda for fourth harmonic, yes. 4V by 2L. We have also forgotten that. String is fixed at both ends. Do we remember string fixed at both ends?
Sir, it is the frequency, no?
Huh? Oh, sorry. I've written V. Sorry. Yes. Sorry. I added throat frequency. Yes. What is the lambda for fourth harmonic? Fourth harmonic for this string. First harmonic, lambda is 2L. Second harmonic, forgotten. So for the nth harmonic, it will be 2L divided by N. Lambda gets divided. Yes or no? Now this lambda is also equal to 2 pi by K. And your K is given as 0.157, which is actually pi by 2, pi by 20 actually. So 2L by N is 4 is equal to 2 pi divided by pi by 20. Dung. And you get your L as 80 meters. Do we understand this? How did you get 40 meters? Can you tell me so that I can understand what went wrong? Can you tell me how did you get L as 40?
Sir, I have used that frequency.
Frequency
4V by 12.
But do you then you have to calculate V first. To calculate V, you will do we will again do omega by K. Does that make any sense? Does that make any sense? Huh? Whatever you do, you will end up with this formula only. Whatever you do. You will end up with this formula only. Anyways, we understand this? If you go with frequency, you have to again find the speed of the wave. And how will you get the speed of the wave?
Sir, speed of the wave is equals to omega by K.
But this is a standing wave, yes. So again, you have to do omega by K. You will end up with the same result. Come from there or come from here. So you look for the easiest path or you look for the longest path? You look for the easiest one or the longest one? You look for the easiest one. Okay. Let us now quickly move on to the next thing and note it down fast. Don't have to note down everything. Apparatus for finding speed of sound. And in this, two things normally come. Well, the first one is known as the Quink's method or the Quink's tube. Quink's method or the Quink's tube. You don't have to really understand a lot about it. What is going to happen? I'm just going to give you that snapshot, but you just need to understand and write it in your own language what is happening here. The Quink's tube looks like this. This is what a Quink's tube is. You have a tuning fork at one end and you have a flame at the other end. Now, sound waves are produced by the help of this tuning fork, and this sound waves will have two paths to travel. One is the green path and one is the pink path. Do you understand the green path and the pink path? Now, in this pink path, this tube can be moved. This pink path, this tube can be moved, and it is normally moved by some amount x. So this end also moves by the same amount x. Now, initially, the blue and the pink path, they are equal. Do we understand this? Initially, the blue and the pink path, when the tube is closed, are equal. Now you can change this pink path. Do we understand this, what I'm saying? And when you move this tube out, when you move this tube out, interference occurs between the green wave and the pink wave. Do we understand this? Do we understand this?
Yes, sir.
Interference occurs between green wave and the pink wave. And the path difference between the green wave and the pink wave is 2x. Do we understand why it is 2x? Because the pink wave is traveling 2x extra if the tube is moved x distance out. Do we understand this? Depending on whether there is constructive or destructive interference, we can find out the speed of sound. This is the description. If you want, you can note down this description. So this is the description of the entire apparatus. You don't have to note down. It consists of two U-shaped metal tubes. Sound waves with the help of tuning fork are produced at end A, which travels through B and C and comes at point D, where a flame is present. Now the two waves coming from different part interfere and the flame will flare up. But if they are not in phase, so when they are in phase, the flame will ignite. When they are not in phase, destructive interference occurs and the flame remains undisturbed. Do we understand this?
Yes, sir.
Now, by moving this rod X, you find out the distance between two successive constructive interference or two successive destructive interference. If it is two successive constructive interference, then your 2x becomes equal to lambda. If it is a difference between one consecutive constructive and destructive, then the part difference is lambda by 2. Do we understand this? For two consecutive constructive interference, part difference will be lambda. For constructive and destructive, the part difference will be lambda by 2. We understand this? Depending on whether they are having two constructive interference or two destructive interference, you can find out the speed of sound in this apparatus using this apparatus. And that is what the Quink's tube is all about. If in the question it says that two consecutive constructive interference or two consecutive destructive interference are happening, then you will use the formula 2x is equal to lambda. If it is the constructive and destructive interference, then you will use 2x is lambda by 2. So basically, depending on the amount this tube has moved, if it is given two constructive or destructive interference, then you use which formula? Then you use the formula 2x will be equal to lambda, and from there you can find out the value of lambda. If you know the value of lambda, you know the frequency of the tuning fork, you can find out the speed of sound. If it is one constructive and destructive, the distance between one constructive and one destructive interference, then your path difference, which is 2x, will be equal to lambda by 2. You will know how much this Quink's tube has moved, and from that you can find out the value of lambda. So either the value of lambda will come as 2x or the value of lambda will come as 4x. We understand this? Don't have to write everything. Don't write everything. You will not understand anything out of it. Don't write anything, everything. Just write if the distance of the tube is given as between two constructive interference, lambda is 2x. Between constructive and destructive, lambda is 4x. Do we understand this? Don't write the language of this. You will not understand it from that language. Just, have you understood what I've told you? Have you understood it in your own language, what I have told you? Write it in that language that you have understood. Don't write the language of the book. You will not understand it. I'll give you 2 minutes to do it. Now comes the next thing, which is the resonance tube, and this is more likely to come. Now again, you don't have to understand what it and how it works. Basically, this pink thing that you see is a resonance tube. Get this? This pink thing that we see is a resonance tube. This is known as a resonance tube. Now, this green thing that you see is a water reservoir. Water is filled. This blue thing is a rubber tube and it has a small cork. Understand the meaning of cork? Valve. This P is a small valve here. Do you see this?
Yes, sir.
So basically you have a reservoir, you have a tube, and then you have a pipe, and in between you have a valve. So what you can do? You can change the water level in the resonance tube. Yes or no? Yes or no?
Yes, sir.
This yellow thing is nothing but a scale, so you can read what is the level of water. We understand this?
Yes, sir.
That's the apparatus which is known as your resonance tube. So basically what I'm going to do is I can open the valve and I can change the level of water. When I basically change the level of water, what is actually happening is the level of water in the tube is increasing or decreasing. I open the valve, it increases. I close the valve, I can change the level of water. Yes or no?
Yes, sir.
That's it. Everything here is explained in that way. You don't have to draw this diagram. What you have to understand is what happens after this diagram is drawn and from where the questions are going to come. So after this arrangement, what happens is this, gentlemen. Now again, remember, I have to determine the speed of sound. So how do I determine the speed of sound? I take a tuning fork and I vibrate it. Why do I vibrate it? Because I want to produce sound. Okay? Do you understand this? Now,
Yes, sir.
sound is getting produced, and what is happening? I'm going to make this resonance tube as an organ pipe, and it is an organ pipe which is closed at one end. Yes or no?
Yes, sir.
And I'm going to see at which frequency both of these match. That is known as resonance. We understand this? The frequency of the tuning fork and the frequency of this, when it matches, that will be known as the resonance. Yes or no? When resonance
Yes.
happens, you will hear a loud sound. We get this? Loud sound we'll hear from this resonance tube. Now, if the resonance for first case happens at length L1, This is how the wave is going to be set up. Then I change the level of water and I find the second loud sound that I heard. That is the second overtone that is produced. For the first overtone, the length L1 is lambda by 4 because I think that this is the fundamental one. Then I change the level of water tube and I look for the second resonance. I am vibrating this. Do you understand? I am vibrating this continuously. So I get the second length L2 and L2 will be equal to 3 lambda by 4. From here, I can find out the value of lambda. The value of lambda will come as 2 times L2 minus L1. I already know the frequency of this. I know lambda. I can find the speed of sound F multiplied by lambda. Do we understand this?
Yes, sir.
So I look for resonance in this resonance tube. I hear first resonance, that is L1. I hear second resonance, that is L2. L2 minus L1 multiplied by 2 is lambda. Got this? You don't have to draw anything. Drawing is just to make you understand this. We understand this? First resonance, L1. Second resonance, L2. L2 minus L1 into 2 will be your lambda. We understand this? Yes or no? No, yes.
Yes, sir.
Pakka?
Yes, sir.
Right? L2 minus L1. First resonance, second resonance. Don't have to write anything else. Don't have to draw the diagram even. This is just for you to understand what is there. Nothing else. The only thing that you have to understand is L1 is the first resonance length, L2 is the second resonance length, and from there, how do you get the lambda? Lambda, 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 lambda. Lambda is what we are after, not anything else. Do we understand this? Okay, we get this?
Yes, sir.
Pakka? Don't have to understand what is resonance tube, what is this, useless. You are supposed to see this resonance tube in your physics lab. Did you see anything like this? Huh? This is the experiment that is done in a physics lab. And I will probably share a video with you. I mean, you can just go on YouTube and probably see a video on this. You can go and search on YouTube, na? Resonance tube experiment, na? And you will see that video and you will understand this. Okay, now sometimes the answer is here. Sometimes this resonance tube is given with end correction. So you have to also find the end correction. Don't worry. Do not worry. Nothing happens. If this is with the end correction, L1 plus X, which is your end correction, will become lambda by 4, and L2 plus X will become 3 lambda by 4. It does not make any difference. Your lambda still comes 2 times L2 minus L1. So even with end correction, nothing changes. Even with end correction, nothing changes. Lambda still remains same. The only thing is the value of this end correction can be found out from this formula. You can put the value of lambda in the first equation or the second equation, and you can remember this formula L2 minus 3L1 divided by 4. Oh, sorry, divided by 2. That will be your end correction if that question comes on end correction. Do we understand what I have done here? Yes or no? No, yes?
Yes, sir.
Everyone understands this? Everyone got this?
Yes, sir.
Pakka, sir? Can I give you a question now?
Yes, sir.
Pakka?
Yes, sir.
Okay. Then I will present, my dear friends, this question taken from your last year papers. Simple question. Take a deep breath. Deep breath. Tell me the answer and stay happy. I'll give you 2 minutes. So we understand how this is done. Yes or no? No or yes? Huh? So basically, what you have to do, you just have to find out the value of lambda, and that will be equal to 2 times L2 minus L1. Do we understand this?
Yes.
And then multiply it by the frequency. Remember, L2 and L1 are in centimeters, so you have to convert it into meters and all those things. So the the speed of sound will be given by 480 into 2 into this is 40 into 10 raised to the power of minus 2 meters per second. I think the answer you are getting is 3. Oops. The answer that you are going to get is 384, and that is your answer. Anyone understands this? Yes or no? No, yes?
Yes, sir.
Or this has gone above our head saying bye bye. I am going. Don't worry about me. Now, this is one question which is there. And remember, this will require some calculation. So if you see such a big question, which will require you to, which will require 2 minutes of reading from your side, what I would suggest is you just leave this question. Okay. So when you see this question like this, it will take some time for you to read this question and get your answer. Getting my point? It is not so difficult to get it. You have to find the speed of sound in air from here. Two conditions are given, but different. They are not doing it with the same tuning fork. They are doing it with different tuning forks. Okay, that is why the question becomes somewhat difficult. I'll tell you how to do this. So in first case, lambda 1 plus E with end correction. L1 plus E will be equal to lambda by 4. So my lambda becomes 4 times L1 plus E. L1 is given as 11 centimeter below our reference line. So L1 will be taken as 11. In second case, you can write it as L2 plus E. And again is the first resonance. So we will write it as lambda by 4. Now this lambda and the other lambda will be different because lengths are different. So from there you will get the value of lambda dash as 4 times L2 plus E. It just becomes a bit tough. Now we have to find out the speed of sound. Speed of sound remains same. So this speed of sound will be F1 multiplied by lambda, and the speed of sound here will be F2 multiplied by lambda dash. You will have to divide these two and get the value of E. Once you get the value of E, you can put this value of E in any of the equation, because now you know the value of lambda. You can put the value of E in any of the equations and you can get the speed of sound. For example, you can write it as F1 into 4 times L1 plus E. You can get it from this equation. So if such question comes, I would suggest that you leave this question, because you will take a lot of time to read it and you might not be able to solve it completely. Do we understand this? What I am telling you? So if a question comes of the type that we saw here, same frequency, same tuning fork, you can easily get your answers from here, because end correction or not, the answer remains same. Yes or no? Here, because of the end correction and two different tuning forks, the answer just becomes a bit more intense. So I would suggest not to do such questions. We are done with your resonance. We are done with your Queen's tube. Queen's tube, I did not find any question. I saw some questions somewhere, maybe in one of the very old IITs. I saw a question and I thought that since that question have come in one of the previous IITs, it may also come in your JEE mains, and that's why I have given you that quiz to you. Okay, with this we come to an end of this one. Two things are left now, which is beats and Doppler effect, which I think if you have a class tomorrow, we will try to cover it in that class. And with this, we can say end to your what? Your waves, and then we can move on to the next topic, which is heat. You can expect one question from waves. Whatever we have done in waves, you can expect one question, and more likely the question is going to be either from the equation of the wave or from this standing waves. This resonance question may come, may not come. If the question comes, it will be of this type, which I have given you, L2 minus L1 wala. Okay, so I've covered everything that was possible. We'll move ahead and wind up this topic in the next class, hopefully. Everyone understood what we have done today?
Yes, sir.
Yes or no?
Yes, sir.
Okay, we'll take this thing forward tomorrow. I'll see you tomorrow whenever the next class is. Take care. God bless all of you.